Hello adventurers! Today I have discovered that graphite can get really messy. I've also discovered that this new crucible that I bought doesn't fit properly in my furnace, so I'm going to make it work by grinding it down. Additionally, I am sandcasting for the very first time, and I have chosen to make a flywheel for a project that I'm working on for my schooling. The project that I'm working on is I am making a pneumatic steam wobbler engine. We're scaling it down a lot. So this is our 3D printed model of our flywheel. As you can see right here, this is what our design looks like. And what we have decided that we're going to do is we are having a dual stroke piston system. So basically what that means is that since it's air powered, there's going to be a port where our air compressor is going to be plugged in. And through that port, there's going to be inlets into the cylinders. So when the air pushes out, it goes into the cylinder, pushing the piston up. The piston moving it up, depending on what orientation it is on its pivot, when it moves up, it's going to spin the flywheel. What makes our engine different is that depending on which orientation the pivot is on for the cylinder, the inlet is going to be on one direction pushing upwards, and then there's going to be a matching inlet on the opposite pivot pushing downwards. So technically it is a dual stroke, meaning that the piston has inlets on both directions, up and down. When it pivots to the other direction, it's going to align with the hole that has an exhaust so that it still releases the air pressure in both directions. So, with that being said, this is our flywheel.
Let me just stop myself right there and save everybody a whole lot of time. This is Tabby from the future after learning many valuable life lessons as to why following the instructions are extremely important. We ended up not using this design and we scrapped this entire prototype out the window. So, what we learned is that tapers are actually extremely important when you're doing sand casting. Without that, it's impossible to remove the pattern from the sand. Or at least it's very, very hard. Also, I didn't even use this one because this is a singular piece and you need two halves to a pattern. From this point forward of the original explanation video that I recorded, the information that I'm talking about is basically useless because it's all relevant to the 3D printed part that I have in my hand. All the calculations that I'm going to continue to talk about in this clip are about the original volume of this piece that I'm holding, and that isn't useful since we changed everything. After rerunning the numbers on SolidWorks, we ended up finding out that the new volume for this piece was going to be 1.63 pounds. And with my last video, we know that the ratio from copper to tin in a bronze alloy is going to be 9:1. So I had to recalculate those numbers, remeasure the amounts that I had, and then I was able to move on into the casting process. I'll show some clips of me messing up over and over and over and over and over again so that you guys can have a laugh, but it's important for me to document all the mistakes that I made so you guys can understand why it's important to try these things yourself to see why they work the way that they work. That's what being an engineer is all about. With all of that being said, for the sake of time and for my sanity, let's just skip forward and get to the good part.
After many tries of trying to get the actual mold to work, this was the first attempt at actually committing and doing the mold, or making a cast of the mold that obviously didn't go as planned. It's very close, but it's inconsistent in its width, I guess. So this is not going to work, but I'm going to keep it because it's the first thing I've ever sandcasted successfully. Well, it's the only thing I've ever sandcasted, and I'm not using it because it wasn't successful, but that's okay, it's still pretty cool. So, conclusion, the biggest problem was that the other piece, this 3D printed model doesn't have a taper on it, it's just straight across, including on the spokes of it, which made it really, really, really annoying. So yeah, this was not not efficient, not usable. This one has a very, very mild taper on it, on all of its components. So hopefully this will actually work, because I am tired of attempting to do the actual mold and making the pattern like 400 times. So maybe this time, we shall see. And hopefully this time I won't think bad thoughts. You have the cope and the drag. The cope is the top part, the drag is the bottom part. You take the drag first and you put it upside down. Then you're going to take the pattern that doesn't have the little points on it, put it down like that. The first thing you're going to want to do is put baby powder on it, so it doesn't stick to the sand as well. Another thing I'm worried about is that this sand that I have prepared today is way too wet. It should be fine now, hopefully, maybe. I still think it's too wet, but we're going to try it. And then we'll see what happens. Okay, so there's some sand.
So at this point in the video, I'm going to start working on making my mold. My biggest piece of advice is to make sure that your drag is very compact in comparison to your cope. So here I'm spending a lot of extra time making sure that I'm pushing down really hard where those spokes are to make sure that all the details come out in my final cast. It's still important to make sure that the cope is nice and compact. Finally, I'm going to be adding some holes to make sure that there's enough room for the gas to escape while I'm pouring, so it doesn't blow up on me like last time. Another hole needs to be added to pour the material, which is called the sprue. I also add a riser so I can see where the material is when I'm pouring. Here you can see how much easier it was for me to remove the pattern from the mold versus when I didn't have a taper in my 3D print. Here I am blowing into the flask to get any excess sand out from where the metal is going to be poured. Unfortunately, I was unable to get all of it out, and later this is going to cause some cosmetic defects in my final cast.
Practice whatever.
I'm not going to.
No, it's not working, but yeah, you will. Yep.
I got all of it in there.
That was amazing. That was perfect.
All right. Attempt number 2 may have really worked. Okay, so it's still warm, but there are a couple issues cosmetically that are just going to be machined out anyways, so it's not a big deal. Otherwise, everything seems pretty damn good. So I would call that a success. especially being literally the first time I've ever done this before. I am not unhappy with how this turned out. And it's gonna do the job that I need it to do, and that's the most important part. So, this is my flywheel, and hopefully maybe I'll make another video of it working later with the rest of the parts in the project. So, yeah. So, to conclude this video, what things did I learn? So first of all, having two halves of a pattern is very important. Second of all, having a straight-edged pattern is not a good idea. You need to have tapers on it so that when you pull it out, the sand doesn't fail. The other thing that I learned is that the gas holes, the vent holes, are extremely important not to burn yourself. I also learned that loose sand can cause some cosmetic problems, which I tried to account for, but it's a-okay. This is still going to function exactly how I want it to, so that is okay with me because it's not here to be pretty. The other thing I wanted to mention is just there's a big difference between water-bonded sand and oil-bonded sand, which I knew theoretically, but I didn't know technically how much more effort goes into preparing water-bonded sand. I just didn't realize how particular the viscosity of the sand is, how important that is to get the perfect ratio of water to sand. I didn't show a whole lot of that in this video, but it was kind of repetitive. You know, you just spray it, you mix it up, you spray it, you mix it up, you spray it until you get the consistency that you want. And there really isn't a way to tell when you're done. You just kind of have to guess. So it's really just on a case-to-case basis on when you're going to want to stop adding water. So with all of that being said, all of these things were not taught to me in my engineering class. So what we were taught, you know, is here's a diagram of what sand casting process looks like, so label each of these parts. This is a gating system, this is the pouring basin, this is what a riser is, you know, or here's the mold cavity. Those things are useful, but on a practical level, things like tapers or loose sand or you know, what happens if you don't add vent holes and you just have a riser, those things are not talked about in class because those are the things that the actual technical people do. So I learned a lot from doing this myself, and hopefully by seeing my mistakes somebody else could have learned something from this too, because that is the whole point of me making these videos. Is here is the real life attempt at doing this with just the limited information that I was given in class. And my teacher did not do a single thing wrong. He's great. I love him. He's awesome. It's just important to me for me to go out and try it myself so that I can see what things I'm missing from the material I'm learning in the textbooks. So I hope this helped somebody. If it did, like the video, I don't know, subscribe, maybe leave a comment. Please leave comments. I love reading comments. So yeah, I hope you guys like this, and I will see you in the next video. Hopefully next time I will be showing this flywheel in action. So I'll see you around.